Hello, this is John from caveofprogramming.com. In this video, we're going to take a look at dynamic dispatch in Rust. So this isn't completely exactly a tutorial, it's sort of me exploring stuff, but I think I've got this more or less figured out, so I'm going to explain to you what I've learned here. Rust is a kind of semi-object-oriented language. There's no inheritance as far as I know, but you can do dynamic dispatch, and I'll show you what I mean by that. Imagine that we did have an object-oriented language. We could define a superclass, for example, animal, and we could have subclasses of that. So let's say dog and cat. So dog and cat are types of animal. And suppose we've got a method, or in other words, a function that's defined in this animal superclass. So each of these has its own version of the speak method. And dynamic dispatch is where, when your program runs, you have some kind of variable, usually, that refers to the superclass type, so animal, but you can make that point or refer to the subclasses like either dog or cat. And at runtime, you can change what it points to. And when you call the speak method, the correct version of that method gets called. So for example, if your animal type variable refers to a dog and you call speak on it, you're going to invoke the dog speak method. If it refers to a cat, you're going to invoke the cat speak method. So this is dynamic dispatch because it is decided at runtime. You can literally ask the user to enter a letter or something to decide what kind of object to create. And then at runtime, if you call the speak method, your program actually has to somehow decide whether to call the dog speak method or the cat speak method. And we can do this in Rust. And I actually needed this for a project that I'm working on, which is a kind of software synthesizer with a tracker style interface, which I'll probably show you in future videos. But I have a need in there to have a variable that can refer to different views, different presentations of information. And depending on what kind of view it actually refers to, for example, the draw method of that variable has to do something different in each case. So I came up against this problem, how to implement this in Rust. And as I've discovered, there are some subtleties around it. You can actually implement a version of this just with basic references with a few sort of tweaks or caveats there. But what I've found is that to get this to work in the way that I wanted, I had to use RC, the reference counter that we've seen in previous videos in this series. So I'm going to show you how to implement this with references, at least if I can remember it. And then we're going to see what kind of problems you can encounter with that. And I'm going to show you how to fix those problems using a reference counter. There are going to be probably a lot of mistakes here because I am still learning this language, but I think I've managed to sort of master dynamic dispatch, at least to the point where I can use it successfully in my program. So first, there's no inheritance in Rust. So what is animal going to be in our case? It's actually going to be a trait. A trait is something that can define, well, sort of define functionality of things that implement that trait, a lot like an interface in Java. So let's have a trait animal here. And we can say that we've got a function in here called speak, and that's going to take a reference to self, the actual object that it's attached to, and we should be able to invoke this method on anything that implements this trait. And now let's have a struct dog, let's say, and that can have a name field of type string, and that's going to implement this animal trait. So to do that, we say here impl animal for dog, and then we can add the speak method in here. In fact, we have to. So let's say function speak. We've got a self reference there, and then we can do something in here specific to the dog struct. So let's do something like, we'll just print I'm a dog called, and then we can put the name of the dog in there, so self.name. And if you are familiar with Java or Python or anything like that, then this is going to look relatively familiar, I think. So that will hopefully work and compile, at least if I give it a main function as our entry point here. Let's try it and see if it actually works. I'm going to just clear this stuff. Cargo format to just format it nicely, and cargo build, and we'll see if it builds. Yeah, so we've got like unused variable warnings, but it does actually build. So I'm going to do the same again, but this time we're going to have a cat. Let's have a cat, implement animal for cat, and that's going to say I'm a cat called and whatever the name is. Now let's take a look at the actual dynamic dispatch aspect of this. So let's say we have a variable, which I'll call pet, and that could be, I'm going to sort of implement this very naively, and we're going to see what problems come up with the naive way of doing it. So let's say let pet, I'll say that's of type animal, equal, and actually we want some things for it to be equal to. Let's have a let dog equal dog, and the name of this dog can be Fido, and we'll also have a let cat equal a cat object, and that's going to be called Tiddles. And then when we create our pet of type animal, we should be able to make this refer to a dog or a cat, because after all, these are, well, at least they implement the animal trait. It's perhaps not true to say that they are of type animal in Rust, because there's no inheritance in Rust. This isn't a superclass, these are not subclasses, but we should be able to do something along the lines of this, and then we'd expect to be able to call the speak method like this, and then later on we would hope that we could reassign pet to something else like cat, and then we could call pet.speak again, and now we'd hope to see the cat specific implementation of this. Now there's quite a lot wrong with this. Let's just see what errors come up when we actually compile it. So I've actually got a formatting issue here. That should be a semicolon, and also there. And if I format it, that's okay. Now let's see if we can actually build it. And yes, we've got a lot of errors here, as I expected. So one problem is that this is a string slice, and this is an actual string that's held on a heap. So this is just a reference to something that's embedded in the executable. So to turn it into a string that exists on the heap, I could use the toString method or the into method, which I don't completely grasp if I'm honest, but that also works. Now let's try this again, cargo build, and then we see some errors are still coming up. So one problem we have is it says expected a type and found a trait. So when we define the type of a variable, we can't just set it to a trait. We actually need a proper type of something there, like an actual struct type or something. But I think what we can do is we can set this to a reference to an animal type if we put the dyn keyword in there. Let's check if this really does work, and probably we want a reference to a dog. Let's see if that actually works though. So yeah, so we've got a problem here with pet equals cat, so I have to fix that as well. Let's say pet equals a reference to cat and see how it goes now. If we're lucky, this might actually compile. No, it doesn't. So cannot assign twice to a mutable variable. So a problem here is that pet is not mutable, so we can't actually change it. I have to put the mute keyword in. We're going to come back to this in a second, and then let's try that again. And now it actually compiles. Let's try running it and see what it does. It says I'm a dog called Fido and I'm a cat called Tiddles. So we've actually achieved our objective here. The key thing here is that this dyn keyword, apparently this is basically for implementing dynamic dispatch. That's why it's called dyn. It is actually for implementing this exact kind of scenario where you're at runtime deciding which speak method to call. So if you've got something that's going to be of a certain type, but the type is a trait, you basically got to put dyn in there to get this to work. And this works with references. So we want a reference to a dynamic animal, I suppose you could say. And then here we're taking a reference to dog, and here we've got a reference to cat. So this all works and it's fine. So for some simple scenarios, it's fine. I suppose we could probably create a vector of animals like this and loop through it calling the correct speak methods. But I want to show you a situation in which it doesn't appear to be fine at all. And I encountered this situation because of some software I'm working on, a software synthesizer, where I actually wanted this stuff to be kind of encapsulated in methods of a struct, and I couldn't then get it to work. And then we need to do something a bit different. So let's take a look at what we actually have to do and what the problems are. So I'm going to write struct, let's call this house. So the cats and dogs, they typically live in houses. So let's put struct house. And then we'll have a function new to create a new house like this. That's going to return self, which here is just a synonym for house. And then within there we can create a house and return it. And again, I could just use the self keyword if I want. So let's put self with a capital S and the brackets there. And then I've done something really stupid here. This is mixing up implementation with definition. Let's take this out for a second. Struct house, I actually need to define the fields here. So the fields that I want it to have would be, I want a cat of type animal and a dog of type animal and a pet of type animal, something like that. As we've seen though, these probably need to be references, and I probably want dine in there. So let's put that in for all of them. See if we can get this to work. And then I want implementation for house. And yeah, that's where my new function goes. I did warn you, I think there will be mistakes here. But this is what I actually want. And now what I want to do is create the dog and the cat in this new method, and then have the pet point to whichever one I want at a given moment. So let's take dog and cat here, cut it from there, and maybe just paste them here. And then I can say here, so I can initialize the dog and cat fields of house with these dog and cat variables, or at least this was my thinking when I first tried this. So I can write that. And then we want pet as well. Let's point pet initially at dog. So I want to like put this here, and then I can put pet in there as well. This is a kind of shortcut for saying dog is this. And then we've got to do something about calling the speak methods. Let's have a function speak like this. This isn't actually going to work, but I will fix it and make it work later on. Let's say function speak, and I'm going to say pet.speak. And then let's get rid of this stuff down here. And I also want some way of switching animals. So at the moment, pet is pointing to dog. Let's at least have a method like function activate cat. And yeah, I already made a mistake there. This should have a self reference, so we can call self.pet.speak. Then activate cat will have a reference to self, and in there we'll say self.pet equals cat. So we just want to switch pet so that it no longer refers to a dog, it now refers to a cat. And the way I want to test this out is down here I'll say let house equal house : new. So we create a new house, and then we call house.speak so we can see who's in the house. And then I want to say house.activate cat like this, and house.speak again. And there are some problems with this, as we'll see, but you sort of might think it would work, but let's take a look at what the problems are with it. It doesn't in fact work. So cargo format and cargo build. So there's all kinds of problems here. So one thing is it's complaining about lifetime parameters, which is fair enough. Let's see if there's anything else that's a problem in here. There are going to be other problems, I think, but yeah, that should be. Here we've got self.pet equals self.cat. We can easily fix that. And we can start putting these lifetime parameters in to see if it actually fixes the issue, which it doesn't. But let's try it. So let's say implement house, and let's say struct house first, and put a lifetime parameter there. And then we can say that all of these are going to live for the same lifetime as the whole struct, I suppose is what we're saying. So I can put a there. We probably also need it here to say that these methods are going to have something to do with this lifetime. So the struct is going to live for that same lifetime, and maybe we'll need it down here somewhere, but let's see what actually happens now. So I'm going to clear this and do cargo build. So clearly some problems here. So we've got expected dyn animal found dog when we try to initialize self. Let me see if I can remember how I fix this problem. So the problem is occurring there. It's occurring at line 41. Now let's see if I can just put a reference sign in there. So we just want references. And what's it say then? That doesn't help, so we can't do that either. So let's scratch this and try a different tack. Let's say dog is a dynamic reference to dog. I don't think I did this last time though. I don't think that will work at all. But so dog by itself is not a reference, and we do need a dyn reference though. So let's just try it and see if it does work. So we want cat here, pet, and we'll leave that at dog. See what happens now. So we clear it and then build. It doesn't like that syntax. What about if I get rid of the dyn? It's not completely sure where I can use dyn and which I can't. And let's try that. This is starting to look like what I wanted to get to. So if we maybe try to just create some blank space here so I can see where the errors actually started. And we go to the top. So we've got unused variable warnings, and then it starts getting into this. Cannot return value referencing local variable cat. So we're returning self from the whole thing. Self has a reference to a cat, but what is cat? It's a local variable. So if we take a look at the code, cat is going to go out of scope when the new method finishes, when it terminates, and we're going to be left with a dangling reference here. And the lifetime parameters, they haven't solved that issue. We've still got a fundamental problem as far as I can see here. So I think this is as far as I can actually get this. I think this is what I had previously, and it was at this point that I realized that a fundamentally different strategy is needed to fix this problem. If we look at the other errors, they're all similar errors as far as I can see. There's this self.pet equals self.cat. That could maybe be improved. We could maybe say something like self.pet equals reference to self.cat. And we've also got activate cat. That's also a problem because when we call that method, it's actually changing the self, the thing pointed to by the self reference. So we need a mutable reference to self. And I think that means that when we do this, we're mutating house. So this would also have to be mutable. Now, we probably boiled it down to the absolute best we can do now. Now, the only errors that are left are ones that are complaining about returning a value referenced by a local variable. As far as I can tell, we can't fix this using references alone, as far as I've been able to tell. And when I tried asking Microsoft Copilot how to do this, first it gave me this suggestion involving references, and when I pointed out the problems and fed back the errors to it, it gave me something involving box. I tried that. That also didn't work. And when I pointed out the errors involving box, it then went back to this solution, which didn't work either. And I ended up going around in circles. But eventually I did manage to figure out enough information using, I think I used Grok in the end. And Grok was able to tell me what I should do to fix this. And the actual fix involves using reference counters. So let's put standard RC and capital RC, and then I think we'll be able to sort this out. So let's make, I think this is good, like down to here, all this stuff's good, but where we go wrong is when we get into this struct business here with house. So let's put here that we're going to have a cat which will be of type RC dyn animal, if I remember correctly, is what we want. We have to have that dyn because this is a trait. And then, so remember, RC allows multiple ownership essentially, as we'll see, and that's going to fix our problem. Let's put let's make all of these RC dyn animal. And then when we create dog, we have to wrap it in a reference counter. So let's say RC : new dog and put a closing bracket there. Then we've got cat. That's also going to be RC : new and wrap that in a reference counter. And then what about pet down here? Now we can use clone if I've remembered this correctly. So if I now do something like dog.clone, that is not going to copy the dog anymore, because what is dog referring to? It's not referring to an actual dog, it's referring to a reference counter that wraps a dog. So we're calling the clone method on the reference counter that's wrapping this dog thing, and that will not clone the underlying data, the actual dog instance or object. It's just going to increment the reference count of this thing here, of this entity. So it's going to say, okay, this has another owner now, and only when all the owners have gone out of scope will the dog actually get dropped. But probably a clearer way to do this, to emphasize that we're not actually cloning dog, is to use RC : clone to do the same thing. And then that makes it clearer that we're actually incrementing the reference count and not actually cloning dog. So now here we can use probably RC : clone and dog. And here we've got RC : clone and cat. And let's put commas in there. And here we've got, well, that can just be pet probably, but maybe it's better just to get rid of this altogether and just put RC : clone dog and get rid of that. So now I think we've got something that's much more likely to work. It's much closer to actually working. When we do self.pet equals the cat, now we just want to clone the reference count to cat here. So let's do, I have forgotten something here though. These have got to be references. We're just passing references to the clone method always. And then here we can say RC : clone reference to cat. And this will probably work. Let's see if this does in fact work. I'm trying to think if I've forgotten anything. One thing is we've now got redundant lifetimes. We can get rid of all this lifetime stuff, which I don't really like anyway. It's so difficult to get your head around it, I find. And then we'll try and let's start and see if we can format it. Cargo format. Yeah, so here I should have put something. Is that wrong? Let's take a look. Expected one of ! or double colon. Yeah, I just forgot to use keywords. So use standard RCRC and then try again. Okay, so it formats and we can do cargo build. Now we have some problems. So for a start, I've got on line 51 cannot find cat in this scope. What's the problem there? It should be self.cat. And then we've got this clone dog expected RC dynanimal found RC dog. Now I'm pretty sure we can actually fix that with some kind of cast. So this is occurring on line 44. Let's try this. Let's say as RC dyn animal. See if we can just cast it. I've kind of gone through different versions of this and I have forgotten a little bit what I did in each version. So now it's complaining about cat. I think that actually worked then. Let's put this here and we'll probably need it here. And then let's try again. Okay, now the build actually finishes. So if I look at what messages we've got here, it's just complaining that dog is never read. Is that really true? So it's complaining about line 29 and saying field dog is never read, line 29. Yeah, it's because I am using this local variable here to initialize dog. So I'm not reading it, I'm just setting it. Then I've got activate cat, which brings in the cat, but I don't do anything with the dog field technically. To get rid of that message, I could just put activate dog and put dog in there as well. And I think that will silence it. Let's try it. Now I've just got activate dog is never used. Okay, so let's try putting in down here, activate dog. I I just want to get rid of these warnings and try that. Yeah. So now if we run it, you can see it finishes with no warnings and no errors. And if I actually properly run it, we've got I'm a dog called Fido, I'm a cat called Tiddles, and I'm a dog called Fido. So to start with, we're getting stuff from the dog object, then we activate cat and we've got stuff from cat. Then we activate dog again and we've got stuff from dog. So this successfully works. So the trick here is not very complicated. We're still dealing with the dyn keyword just because we've got a trait. There's this little sort of twist that if I define these like this as dyn animal, I then have to cast them here. But I think I could also have defined these as dog and cat, and that would have reduced the number of casts that I actually needed. And apart from that, all we're really doing is just wrapping these things in reference counters so that this problem with this being a local variable just goes away, because at this point the dog object, if we didn't have the reference counter, would be owned by this variable, which goes out of scope at the end here. So if we then tried to get a reference to it, we'd have a dangling reference. But now, because we're doing clone here, this means that effectively this gets kind of co-ownership along with this variable. We've kind of got a reference count of 2 now, because this and this are both hanging on to dog. And then when this is dropped, it's not a problem. We've still got something here that holds a reference to dog. So the whole thing works. Anyway, this is just what I wanted to show you in this video. That's basically the whole thing. So once you start trying to implement dynamic dispatch, but you want to do that in some kind of function or something where variables like this are going to go out of scope, and reference counter is a lifesaver here. Another thing you could do is, here I'm not mutating any of the animals. I don't, for example, change the names of any of the animals. If I did want to do that, I'd probably want to not only wrap the animals in a reference counter, but I'd want to also wrap them in a ref cell so that I get interior mutability. And there are other possibilities there. So if I wanted to involve multi-threading in this, where I'm passing the objects to different threads, I might want to use arc and atomic reference counter instead of just reference counter. And instead of ref cell, maybe I want to use mutex or read write lock, RW lock, which enables me to have multiple things reading and one thing writing the objects at a time. But that's a topic for another video, which I might well make a video on if you're interested, because if you want to do kind of MVC in a way that's thread safe, I've discovered you do have to get into going beyond just RC and then ref cell, which we've seen previously in these videos. Okay, so that's it for this video. You can find this code, and I'll probably put a bit of a write-up on blog.caverprogramming.com, so you can take a look at it in detail if you want to use this kind of thing in your own projects. And until next time, happy coding.